Hello. This video is for questions 22, 23, and 24. So I'm on this page of the diagnostic test, 22, 23, and 24. Now in this video, I'm going to use another test correction technique, actually writing on the stickies, which is a pretty good idea, especially for this question, because I'm looking at these tables, and right off the bat, it's looking like these are probability problems. So I'm going to write the word probability. I'm also keying in on the fact that both, or one of the questions at least says, what should you expect? Okay, and that's that. There it is. Aha. So I'm going to have to figure out, I should expect, when I'm looking at the problem here, that a corporation has to have service workers working on the phone lines, and that if they end up having that guy come out, it's going to cost them $50 per visit. So it's kind of a lump sum charge if the guy shows up. In any given month, what would be the probability of the distribution for the number of service visits that you should expect? So it looks as if there is a very low probability of coming out 4 times. That would only happen 3% of the time. And actually a pretty good likelihood that nobody comes out at all that month. So that looks like 38%. And so the values range between those two. And so once again, I think another one we did in a previous video, when they say the word expect, I look at my formula sheet and I write the formula for expect, E parenthesis X, which is actually mu sub X, sigma, X sub I, P sub I. Sounds fancy, works out pretty simple. So all I'm going to do here is figure out what the X value is, and it appears X ranges anywhere from 0 to 4, and then multiply it by the probability of that outcome. So I'm going to take this number times this number plus this number times this number times this number, and then this number times this, add them all up. And like we did in class, sometimes it's easier to do in my simple calculator. I think this one's probably easier in the fancy calculator. So let me write this out. So once again, just like I show in the table, I'm going to take the X value times the probability of X, and I'm going to keep going until I've exhausted all the probabilities. When I add that up, I get 1.17, and I look at my choices and I say, what happened? I'm not getting any of those values. So I'm going to read the question again. It says, on average, how much should the company expect to pay for those service calls? So we don't pay anything here. We pay 50 bucks there. And so it looks as if I'm only expecting each month to have a little bit more than one visit. And so I think logically it makes sense that I just need to multiply that. If I'm going to expect to have 1.17 visit, if I multiply that by 50, I get the number 59. And that's my answer. So I should budget for $59 for service calls because on average, that's how often someone's going to come out. Next question, pretty similar. It says, refer to both question 23 and 24 for the same table. When I look at it, X is the distribution of the number of copy machines needing repairs in a given month. What's the probability of fewer than 2 repairs? So any kind of wording like that, fewer than, greater than, no more than. Once again, a probability question. So fewer than 2. So what I like to do is I like to write out all of my possible X values. Just jot those down. So I'm going to do that on my sticky note. 0, 1, 2, 3, 4, 5. So that's all my possibilities. The copy machine might have anywhere from 0 to 5 repair needs in any given month. And they only want me doing fewer than 2. So 2 is not fewer than 2. 3 is not fewer than 2, 4 is not fewer than 2, 5 is not fewer than 2. So ultimately, and it is also in my formula sheet, under probabilities, that if two things are independent, I can just add their probability. So if I know the probability of no visits and 1 visit, just add those up. So the probability of no visit is 12% of the time. The probability of 1 visit is 18. If I add those two numbers, I get 30. 0.12 plus 0.18 is 0.30. That's one of my choices. I'm feeling good. Moving to the next question. I've got, what's the probability of the machine will need repair at least twice, but not more than 4 times? So I'm going to repeat the same technique. Write out my possible x values, 0, 1, 2, 3, 4, and 5, at least twice. So I always use the same example. If I told my daughter you can bring at least 2 friends to Busch Gardens, that means she can bring 2 or more. So at least 2 would be 2. 2 would be okay. 3 would be okay. But it says no more than 4. So it sounds like 4 would also be okay. So these are my acceptable values. And 5 would be more. And 0 and 1 is not at least 2. So I just need to know the probabilities of these 3 outcomes, 0.23, 0.20, 0.14, and then make sure I'm adding those up. When I do, I end up getting 0.57, and I notice that's one of my choices. Thank you for joining us.